We talked about the structure, focus, which I'll need to quickly remind myself what it means. The structure is the thing that we're trying to work with, like the data type, and the focus is the thing that we're trying to focus on. So in this case, we're focusing on this int. Okay, so structure, focus. We need a getter and a setter to create a lens, and then we can create the lens for this data type here by creating the name, and we just give the getter and the setter, and that's basically a lens. Okay, so congratulations on writing your first lens. Wonderful. So view just extracts the getter function from a lens. Okay. So we have a ship. Purple pearl. $38. All right, so we have this. Oops. And then we need to open up like, hey school bus, what's going on? I think I've called you fake and school bus. I haven't decided what I want to call you. I think fake sounds weird, so school bus sounds better. Could call you magic school bus, that could be fun. Although that's not your name and it would be weirder. But anyway. So right now we're basically just looking at the code we did last time. So we wrote a lens for our ship type, and now I guess we're just playing around with it. So if we have view num crew, it's a lens we defined. Oh, but we don't have view. We need to import control lens. There we go. And we could also view name, I suppose, and that would work. So school bus. If you know how, I think you've watched enough, you've seen the screen tearing up here while doing OBS stuff. Could you let me know if you see that at all today? I literally switched window managers and I'm hoping that it goes away. And I didn't see it last stream, but if it shows up this stream, then we got a problem. So we'll see how it goes. Okay, we could use set to say set num crew. It takes the lens num crew and a. Okay. The lens. You mean bar with apps list? I don't know what that means. Oh, like up, I see what you mean, like up here. Yeah, it's kind of like in this general vicinity that you'll see it. And it only appears every once in a while. So if you're not like actively paying attention, you might miss it, and that's totally fine. Like if you do see it, let me know. It's pretty obvious, but it's a little bit below that, typically like right in this area. It's not really just located directly there. Okay, so we can use our set to use our setter, and well, our lens that pulls out the setter and change things inside of this. So that's kind of interesting. I suppose we can do as well name Black Pearl. Is that the ship in Pirates of the Caribbean? The Black Pearl? Or where am I getting Black Pearl from? I don't remember. Anyway. Okay, we have a getter and setter, and it seems like we're probably going to get a bunch of other functions. So I know over does modification. We could do something like over name plus plus pearl, purple pearl. So like we can append a exclamation point, or in this case we can add 3 to the number of crew. So it's just a combination of a getter and a setter. This is interesting. Oh, right. We're viewing the thing and then adding 3 to it. Okay. Interesting. Automatically generating field lenses. Writing getters and setters by hand is mechanical, boring, and error prone. Boilerplate, sure. We can use template Haskell to write them for us. So what we'll do is a lens is basically 2 things. It's sort of a data type. So you would write a lens for a particular data type, in this case ship, and all you need to do is have to define a lens is be able to describe a getter and a setter. So in this case we're describing a lens for the num crew field. So I guess the way people normally write this is still use an underscore in the record and then use the define the lens without the underscore. So in this case, we're defining a lens with the getter, which is just the field constructor. And then we also need to define a setter. So we just use the record update syntax to say, if you give me a ship and a number, I can return to you a ship where I update the number of crew with a number. So basically every field will have its own lens in the record. Does that make sense? Or maybe your question is more generic than that, but that's kind of the idea. And then the nice thing about doing this is that you get all kinds of functionality on top. So like we can say things like this, which is like over, which is a modify, over the second piece of this tuple, aka int, you can multiply it by 10. So it's like, given this tuple, I could multiply this 2 by 10 using this over function, because tuple has the lens underscore 2 defined for it. So this right here is a lens, and down here we have our lens, which is, or well, down here I guess we have our lens, num crew, and name in this case. So that's what I know so far about lens. I think there's probably a lot more to discuss, but that's where it starts. All right, so we have template Haskell here, but we haven't used it yet. So I think that what we'll do is we'll comment these out, and we'll use the make lenses function on ship. Okay, so I presume that this make lenses function will create name and num crew by just removing the underscores, and then give us the lenses for these things. Yeah, and this is like some template Haskell syntax, the prime stuff. I've not done a lot of template Haskell, so like this is relatively new to me as well, but I know that this is template Haskell. I've seen it before. So this will generate appropriate lens for each field in our ship record type. By default, it chooses name for the lenses by stripping the leading underscore. That was my guess. It'll generate the exact same lens we wrote by hand, and will even have the same name. You'll need to delete, move, or rename your lens from num crew if you still have that sitting around, which we did. We commented it out. So actually, I should put a note here. Okay, so now we have make lenses, and we can reload, and I presume, oh, we need to import control lens, and then we should be able to do like the same thing. Yeah, so we still have our name function, and the lenses still work. Okay, make lenses does the right thing, so I recommend taking advantage of it whenever you can. Yeah, it's like, you know, it's library code, so someone else is maintaining it and you do not have to, which is convenient. Make sure you do try writing a few lenses by hand. It's a very good exercise when you're learning. Yeah, we should do that. I agree with that. Template Haskell will never slow down your code, right? It's actually just writing code for you at compile time. I think there's a way to dump out the template Haskell that's written as well, but I don't remember exactly how to do that offhand. Okay, if you want more control over the names, you can provide additional rules using make lenses for and make lenses with. Note that the position of template Haskell expressions within a file matter. Oh, that's okay. You can imagine that each template Haskell expression splits the file into two modules. Whatever is above the expression, whatever is below. I didn't realize this, so this is interesting. I didn't know that it mattered where that was. Okay, that's interesting. So if you're not using them in the same file, then it doesn't, well, it matters, but less, because, you know, they're not being called in the same place. Okay, so we can check that everything is working. Yeah, we've already looked at these, but here's the type of name and the type of num crew. So you can see it's got this functor f string to string. So this is our this is interesting. View. Okay. Yeah, I'm kind of surprised by this type, but okay, so here are a few heuristics to help you guess what's going on in optics types. If you see functor f, it's probably a lens. The focus of the optic appears first and second in the signature. The structure appears last and second to last in the following signature. Okay, so this is the structure and this is the focus. Okay, this is the focus. Int is your focus. Ship is your structure. Okay. Browse. I think I'm going to write lib here because I don't have my lenses. Yeah, so we can see name and num crew are lenses with the structures and the focuses. Okay, so now we have some exercises. So exercises, records, part 2. So using, I think this is still lenses and records. Lenses and records. Records part 2. Oops. I do need that second one. I wanted to get rid of the first one. List the lenses which are generated for the following code. Data. Inventory. Inventory. Wand. Book. Potion. Book. Whoops, forgot a G. Wand. Potion. Doesn't really matter. We're just trying to make this compile. I suppose I could do this instead. Oh, but then I have to define it down there, so yeah, let's just not do that. We'll just do this to make the code compile. Prutz, how's it going? How's your day? All right, and if we wrote make lenses for inventory, we would get the following lenses. Wand, which I guess is functor F, and then we get, in this case, wand to F wand. The focus is, wait, what would we be doing here? We want to get at that string. So I think that this would be string to string in this case, but we don't know what wand is. Including their types. Okay, so let's actually remove these and make this a data. I don't fully understand what these lenses would do. Okay, then, so that's the focus, the structure. I think it would be like this. Oops. And then book, potion, and this would be wand, book, G. Oops. Potion. I think this is right. We can come back to it. You choose F appropriately, you can get or modify the inner field. Yeah. But what I mean is, how would we write a function that converts from wand to wand? Like, what does a setter mean when there's no, like, inhabitants? or exactly one inhabitant in this case. Like, what does a list of potion mean? Again, we there's no types defined here, so it's a little tricky, I suppose. Like, if a wand was in fact a wand that contained a name or something, like a string, then I suppose that we would modify the inner string. But there's, in what I've written here is not really complete because we don't know the data types here, so it's a little awkward to write these, I think. But anyway. Okay, so rewrite Hey, Chris. Yeah, I think I understand that, Pretz. So pretty good so far. Glad to see you're hanging out again. I got my physical copy, by the way. Did I have it last time? I can't remember. I was pretty happy about that. Got it in the mail like 2 days ago. But since you're allowing me to show the book here, I won't use a physical copy. All right, so rewrite the following type as lens. So Gazork. Gazrock sounds more like a Swedish metal band. Spuzz. Spuzz. Chumble. Okay, so first we need data spuzz, data chumble, and then Gazork. Nope, that one. There we go. All right. So rewrite the following type as a lens. Oh, yeah. Okay, no, I see what you're saying now. Wand. No. I see what you're saying. One of these is supposed to be inventory because one of them's structure. So I think these ones are, the first side is incorrect. No. This is inventory. You did spoil a little bit, but I think this, I now get it. I mean, when I looked at the solutions, it would have come up because I was just, writing the solution anyway. Oops. Yeah, so the structure is an inventory, and then this acts as a getter or setter for wand, I suppose. And this also implies that spuzz is a type that's inside of here, so it's like spuzz. Sure, you can be a new type. So what does this mean? This means that Gazork is a lens of spuzz chumble. I don't know yet, but it's some f chosen appropriately to basically turn this into a getter or a setter, or is it both? I don't fully understand yet, so I'm not sure. School bus, but I think this is right. So I think the structure comes first, so it's a chumble spuzz. It's fun to say. I think the structure comes first. We'll look at an example up here. Structure comes first. You plug const inventory for f. You can use wand const expression as a getter. Yeah, okay. So that, yeah. Choosing f appropriately allows you to write the const or sorry, a getter and a setter. So this can behave as either, I suppose. Okay, so I think that's right. For a setter, it probably has to be, I'm not even sure. Yep, we did this. Wand identity. Okay, so this code's not going to compile, but it's going to be a little awkward because we're inside of a... I'll just have to not look at the type error and think about it. I suppose I could just stare at it first and then go from there at type. Get pet name, if I could spell. Pet string, get pet name, pet view, pet name, pet. Oh, I think the bug is that I need to put the make lenses up here. Which that's something I didn't know about Haskell. Oh yeah, and then this can just be, oh, interesting. I figured it was going to, this can just be view pet name. Yeah, that's something I didn't know about template Haskell. We can't define, like we could define this view, like if we defined our own custom view function and not using the one from lens, we could put that wherever we wanted to in the source file. But the way template Haskell works is it kind of splits the thing in half. So if you want to use the definition pet name down here, you have to put the template Haskell above it. Or sorry, maybe a better way to say it is we could have written the lens like this, not like that. Where is it? I commented it out, so it's gonna be hard to see. Like we could have handwritten the lens for pet name, and that could go anywhere in the document, but it cannot go below this if we're using template Haskell. Anyway, I presume that when you're writing these, you're rarely going to write a function like get pet name before you would write make lenses. So like these things would probably be almost always tied together or very close to each other in the code. Anyway, and you can see the error if we do it down here. So let me put this down here. And then you'll see variable not in scope pet name. So that's where the error comes from. Is that interesting? I think so. I didn't know that about template Haskell, so definitely learned some stuff already. Okay, so far we've only built a few simple lenses, but hopefully your mind started churning out ideas of other cool lenses you could write. few limitations, okay? Which can't lens. An optic which inventory wand for a getter. And then for a setter, we use identity wand to identity wand, I guess, based on what you were saying. Although you did say modify at some point, which is not necessarily a setter. Yeah. Okay. So can or can't be made into a lens. An optic which always accesses exactly one focus. Always accesses exactly one focus. There are certain things you might want to do that don't fit into the idea of focusing. In most of these cases, there are different type of optic which can do that, but it's helpful to explicitly recognize a distinction. Let's make a game of it. Step on down to play. Is it a lens? Okay. Text-based game show. Nice. I like it. The rules are simple. Okay. Yes or no questions. I'm into it. Oh, we forgot to look at the answers here, but I think we have these answers. So let's just check. Oh, we wrote it in this style, but it's the same, right? We went sort of back and forth this way, so it's the same. Pretty sure. Oh, except it's not potion, right? It's list of potion. Potions, I think, is probably just me mistyping something. So we were close. I made a mistake. Okay. So we're going to learn about this specialization at some point, it sounds like, which is good. And it should still be inventory, inventory, and then book, book, wand, wand, inventory, inventory, I think. Pretty sure that's right. And we got this one right, I think. Lens chumble spaz, which is still fun to say. And then this code is just because the make lenses needs to go in the other place. Okay, and then back to questions. Okay, so now we can keep going. It does realign this, which is interesting. Okay, so is it possible to build a lens which focuses the second element from a 3-tuple? The second element from I assume it means the 3-tuple. And my guess would be no, because there's 2 of them, but it seems like you could. I don't think that's right. Oh, right. Okay. Here's the structure. This is structure. This is the focus. Yes, 100%. Okay. Oh, except it won't let me go back. Unfortunate. Would you mess up? Okay. Yes, basically the same reason. And I suppose we've already seen these lenses, so this might be a little too easy, but that's okay. Because we would just use, I'm pretty sure it's just called underscore. Oh, but there's just and nothing, I suppose. But maybe you only use the just. I don't know. I'm gonna say yes. Chris, I enjoy your writing, by the way. This is very funny. You see, lenses are for products and maybe is a co-product. Okay, we'll look at the answer here in a second. But my feeling is the answer is yes, a lens could be made for this, but maybe not. We'll find out. I'm going to have a feeling that this is also yes, but I feel like some of these have to be no, so we'll have to see. Hey, Miliardo, I saw you followed earlier, so thank you for that. But it was before we started streaming, so I only call that stuff out if I see you hanging out, so thanks for coming to hang out. Prisms are, let's see, in whatever this chapter is, but basically about 150 pages away. So, but we'll get there. I promise. I promise. Okay, so let's see. Okay. Yeah, so that's what I was thinking is I thought that we've seen this just lens, but we can't deal with the nothing. So there's no generic way to deal with this because you don't know what to do with a getter on nothing. Okay, and I guess this for the same reason is this is true. Oh, okay, but either is interesting because you can write a getter for this case. But what does a setter do, I suppose? Could see how modify might work. You can't always get and set a string for every possible value. Slightly alter the type. Interesting. Okay, I suppose this makes sense. Okay, so we need prisms to deal with that. Interesting. I have not yet talked too much about coproducts in oh right, this is just attached to this, so I can just keep scrolling down. Oh, we're not done yet. Okay, so I need to think about getters and setters. That's the idea. Just focuses the third element of a list. Is this like you don't know if it exists, so how could you write a getter or setter? I'm gonna guess the answer is no. But I don't know, right? Because it could exist. Like you can write it to say, look, your getter and setter will only ever touch the third element in the list. But it may or may not work, which is different than the other cases. Because there's no way to write a getter for nothing. Let's see. Yeah, okay. So okay, I was close. My logic is bouncing back and forth. This is a little annoying that when I click that button, the focus moves. Okay, tricky one. Can you write a lens which focuses the second element of a tuple focuses the third one if it's false? I feel like this is one we could probably try to do. So we need a structure, so we can just define a type conditional, and it can just be bool A. And then we're gonna just try, maybe it would have made sense to just try writing a lens for all of these instead of just thinking about it in my head. Anyway. Okay, so we want to write conditional lens structure so a getter would take it doesn't really matter. We'll just put string here. And then we can write getter. And we'll just write setter here. How do we write a setter in this case? Well, I guess it's something like the following. So we're gonna get the structure and the value what am I missing? Takes the structure and the value to change and returns the new structure. Oh, but this returns an A. I feel like I'm confused. Okay. Where'd it go? Okay, so this one, we need to pull out the value. So I need to have a string, right? Okay. I have to make string explicit. So I think that this is right. Yeah, no, you're right. Thank you. So I think it's valid. Mm-hmm. Okay. I'm not even sure what make lenses would do in this case. So I suppose we should check. Add error. Exit code. Okay. Wait, what? that can't possibly be the way that that's supposed to be formatted. I would probably format it like this, or align the brackets, but it does not want to do that. Anyway, okay, so there's that, and then we'll reload and browse to see what it actually makes. So code, so it does make lenses for these fields, which is nice that you can define this. But it's a traversal, which is different. So let's comment this out and see if we can write it ourselves, which I'm going to presume that we cannot if it's giving us this interesting traversal thing, but I don't really know. Oh, I guess this is kind of the same as before. Like if we get an exit code, how do we write a getter, or sorry, I guess how do we write a setter for an exit code? I don't know, let's try it. Yeah, how do you write a getter? Oh, you can't write a getter for exit code that returns a string. So yeah, impossible. Which is probably this is probably like the co-product thing that you guys were mentioning before, which is why this is a traversal. Maybe this is like a prism. I don't know. I don't see how you write a getter for this, because you can't deal with an exit code. So yeah, I think that makes sense. So it's kind of interesting. Traversal is more general. Okay, interesting. And then we can just jump to answer. Gets a bit weird. The setter could just do nothing. Oh, the setter. Okay, but what about the getter? Do you know it needs a string? I suppose you could just return an empty string. Yeah. Okay. Yeah, like you could use mempty or something like this, but it would be strange. Just toString. Okay, so we'll learn about, maybe there's a separate section for, oh, there is, look at that. So we'll actually learn about traversals before we learn about prisms. So yeah, it's a chapter all of itself, all on its own. Okay. Interesting. Well, we'll learn more about it, I'm sure. It's interesting to see that you can have these some types like this and you still get the right thing, which is kind of nice. I've been playing pretty fast and loose with the rules, types, and laws around lenses. Okay, academic rigor. Okay. Why do optics have laws? Yep. So we're Haskellers, so we're okay with these kinds of statements. That would be a problem. Having laws tells us how well behaved. Is there like a quick check plugin for lenses? Or it's not like a plugin, that's not the right term. I think we used something called checkers before. Okay, wonderful. I think it was called checkers to do like type classes. Really meaning equals. Hedgehog. Okay. Have you ever used Quick Check, Chris, or no? Just that. Okay, so we can play with that as well. I've used Quick Check before, and actually I've used Hedgehog as well, but I'm more familiar. At least I have examples of Quick Check readily available. But I think we actually did do a Hedgehog stream at some point. I just don't remember where that code is necessarily. We might be able to find it. Okay, so the laws. Nice. Lens properties. Oh, it just depends on Quick Check, so is lens. Nice. Is setter. These are always nice because they usually give you the examples of like what are valid for these pieces, which is useful. And then I suppose the only thing you have to be able to do is define like these co-arbitrary instances, for example. Well, I guess, I mean, they need to be instances of everything here. You just have to pick data types that are relevant, which is something that I probably do incorrectly when I've been using Quick Check before. Like I would just use, I don't know, string, int, and that probably will work with all of these. And that's probably not the best idea. Anyway. ISB. ASB. Int string bool, I'm gonna guess is what that stands for. Got it. That was a good guess. I mean, I have context, so kind of helps. Oh, that's interesting. Look where that highlighter shows up. Huh. Okay, I don't really know why it's highlighting just the two data constructors, but anyway. Okay, so laws. A few laws. These laws are mostly guidelines, but following the laws helps make lenses more predictable, and things will still behave properly when we pass the lenses off to helper functions or combinators. Typically, you should follow the laws when writing field accessors and basic data accessors. Emulate virtual fields. I don't know what this means. What does emulate virtual fields mean? Input, cleanup, correction, yeah, imputation, something like that. But I don't really know what this one means. Look at some examples later. Okay, cool. Here's a full list of the lens laws from the lens library itself. Use equal equal here to mean that both left and right side should be equal. Okay. So if we set a new value into a structure and then view it, we should get the new value. This is interesting to me, right? Sometimes I forget that lens right, this implies that this view set process is actually mutable, right? Like my lens itself. Oh wait, no, this is the my lens. Never mind. Ignore me. Ignore me. This is the lens, not the structure. Right, so this thing returns a new structure, and then we could view it using the lens. I'm thinking incorrectly. Okay. Setting back. Well, I'm just gonna read the code. View my lens structure. This is like an identity operation, and then setting it with itself should be the same. Yeah, this makes sense. This is like an identity operation. Setting twice is, yeah, so it's idempotent. Been using the word idempotent a lot recently. It's a great word. Set my lens different value. Oh wait, this is not idempotent. This is, or it's not an idempotence check. It's a it's like an order check. I don't know what the right term is here, but yeah, you're setting one value and then setting another one, and the second one better be the one that persists. Yeah, there's no, I was hoping for terminology, but I don't know exactly what the right terminology is here. Okay. Are there any, yeah, consistency, that would work. Are there any examples? No, just because, like, you know, the like setters should be consistent, right? If you set and then set again, you know, the second time you set better be the value that's stored. Filtered is the canonical law-breaking useful optic. I think you talked about filter at one point, but I don't remember exactly what it did. So that's unfortunate. Let's see some code. I kind of really want to test this with quick check just for fun, but maybe it's overkill. I guess capitalization doesn't really matter, but Firefly, view 1, set 1, new value, Star Wars, Star Trek. I would say that this action is quite controversial. Right, and I guess the whole point is, yeah, this should be equal to the value. Replacing Star Wars or Star Trek with Firefly. Although I was a huge fan of Firefly myself, so. Oh, look at that. You even mentioned quick check. Okay. Oh, I don't need lat. So yeah, that's like an identity operation. And then this is the setting, or what we talked about is like consistency or something. Yeah, anyway, okay. Okay, so this is our unlawful. Just ignore the new message. Sure. Okay, so set get is okay. For really bad error, but not for exit code. Okay, lens product. I might play more carefully with this one because it's new. Law breaking lens product. This lens is actually provided by the lens library, but it's in control lens unsound to indicate that you should be careful when using it. Okay. Let's bring this type user name string type user ID string data session user id name user name created time string. Oops. Okay. Mm-hmm. We want to dive into the session to operate on the user ID and username, but don't care about the created or expiry times. You can then use lens product to take the product of the user ID and username lenses, creating a new lens over the tuple of their focuses. So to do this, we need to import. Oh, actually we can just do it up here. Import control lens unsound lens product. And then down here we can say user info lens session user ID user name. Guess that's the focus. User info lens product user ID user name. So those are our two lenses that are made for us by Make Lenses. Lens, plural. Okay. So then we can do session 2, 3. What is it? The ID. So 0. Don't care about this. View user info session. Neat. The lens we've constructed here actually is lawful. Not every lens we can create with lens product is illegal. The issue is that to be able to create illegal lenses, the issue is that it is able to create illegal lenses. In order to stay lawful, we must ensure that the two focuses are disjoint. They don't have any overlap. If we instead, like, why can't I speak English? Hey Daniel, what's going on? Let's be lazy. We're using Haskell. If we instead decide we want to pair up the user ID alongside the entire original session, then we have a problem. So, okay, we use id as a lens. Seems a bit magical until we understand a bit more about underlying encodings, which we'll get to later. We can pretend id has the following type: SS. Sure. Structure focus. Our two focuses are not disjoint, they're joint. The user ID we focus in one half of the tuple is also present in the full session. So we'll look at this. So we have the session. We have a new session where we change the user ID. Along, oh, right, this is the lens. Then we set new session. Session. So we're replacing user 1, 2, 3, 4 with user 5, 6, 7, 8. And then we're replacing again new session with user 999. Okay, so we end up with this. User 999. We can see that the user 999 change has overwritten the user 1, 2, 3, 4. So, oh, right. This is session. View. Set with new session. And then view it. So it should just be this. Okay, I'm okay with that. And then this is exactly the same. But this new session should be user 5, 6, 7, 8. Okay. Okay, I see it. I don't know why that took me so long, but okay. So implement a lens which breaks the second. Okay. So we'll go back here, see if we can do these. So exercises, laws. What section are we in? Lens laws. Lens laws. Laws. So type. There's a different way. Could have written the message lens such that it would pass the set get law and the set law. Okay, so rewrite message such that passes the set get law and set law, but not get set. Okay. I don't know if I'm gonna be able to do this. Think up a law or a lens. Yeah, these ones are harder for sure. Is still useful. Breaks a law or two. Write a lens which violates all three laws. My goodness. Yeah, that's fair. Yeah, I mean, you don't have to actually solve it. Write a lawful lens for the following type. Data builder. Yeah, I think the only trick here is that like we don't have a lot of experience with these things, so it can be I think that is more the problem for me anyway. I don't remember what letter we're on, so we'll just use Z. Okay, and then we need to remind ourselves of the laws, so let's do that. So I think it's just bring these up. Or write them down, rather. So set get. I don't know if this is actually a useful symbol for this. You would usually use like, I mean, equal is probably fine. Yeah, just write it out. All right. and or. Okay. So we need to violate this. I mean, I suppose we could just write really wonky code to make this work. Feel like I suppose, but not. The goal, well, I'm not really sure. Is the goal to make this one pass, or is it just ones that violate these? Because I presume that you really want this one to pass, but these ones to fail. Well, one of them, or both of them. Oh, okay. So and is easier than or. But we really want it to pass the first one, I suppose. Let's look at some of the examples we have thus far of failing ones. Oh, okay, gotcha. So what is this? This is our set law, right? No. View. Okay, this is the set get. So we want this one to pass, so this doesn't help us. These kind of exercises I'm not good at, like, at all. If anyone tells me to make something up that violates something like this, I am terrible at this kind of stuff. All right, so let's look at one that passes, or that fails. This is set get, so that's not going to help us. This code is straightforward, so no good. And this one's also straightforward. I'm not going to be able to do this. Like, this is not something I can figure out. Just going to be honest with you. I don't think I'm gonna be able to do this. Oh, okay. Well, yeah, we can look at the answers. I need examples. Like this I can do, right? This is perfectly reasonable. Test laws. I can do that. That's no problem. But this I might be able to do. I don't think I'm gonna be able to do this. I mean, you already told me some examples, but if I'm supposed to come up with it, it's just not gonna happen. I think I could do this one because I could just write a really strange lens that doesn't make any sense. Like, have a data type and a lens that returns, well, maybe not. Like if I just return a string from something that doesn't even contain string and then just make it empty, does that fail all the laws? No, I kind of want to try that. Constant lens. That's an interesting idea as well. So let's try this first. So I think I put Z down there. So let's make this Y. So what I want to try and write is like, let's create a new type, I don't know, Y. Lens Y string. Well, I can't define a setter for this at all. Well, I guess I can, right? Because the setter can just put a 0 in there. So lens getter setter. We'll see if this actually fails all the laws. I'm not even sure. So we need so this is going to take a lens, not a lens, a Y, an int, and an int. Oh, duh. So this returns a Y, so this can just be, sorry, types are all wrong. There we go. Okay, so does this pass any of the laws? Let's find out. So Y set get view Y set Y new value. New value is a string, so it can just be empty list, doesn't really matter. Well, no, it has to be something else. ABC. The empty list is the special case. The structure can be I don't know, S. Actually, the way we should do this is make this aware so I don't have to use all these funny names. So new value ABC, structure is going to be Y10 something. So this is going to be structure, new value, new value. Okay, so that should fail because when we set y to the new value, it's basically ignoring the new value. So this should fail. Oops. R. So y set get false. View y set y new value structure equals new value. Great. Okay. So that fails. Wonderful. This one feels like a situation where I can actually handle it. The first one's way more. Actually, I feel like the first one's the hardest one. Maybe. Because some of them have to pass and some of them don't. Or something like that. Okay, anyway. So we want to do y get set ready set go. And this is going to be set y view y structure I probably wrote something wrong. Set. I'm missing structure, aren't I? What am I missing? Missing something. Yeah, I'm missing structure. We need to be able to compare these, so we can say deriving eq should be able to compare integers just fine. And then we can just reload and do y get set, which should fail. Okay. And then y set. This one I'm concerned would pass, just thinking about it, but don't quote me on that. Set y diff set y val structure. Set y diff structure. Where? So we need to define diff. We need to define val. We need to define structure. So structure can again be y10. Diff needs to be a string, right? Yep, and val needs to be a string, so CBA. Doesn't really matter what they are. And then that should also be false if this works. Reload y set. Yeah, this one's true. And it's because of the way the setter works, because the setter always returns y0. So how do we get around this? How do we get this to fail? Like, we could say s len length. Sorry, I was writing Python today. we could embed the length in here, and then that should be fine. And then this needs to be like WXYZ, and then I think that these would fail. Oops, keep writing E for some reason. So Y set get false, Y get set false, Y set still true. Oh right, because I'm setting Y, right? Set Y diff. I would need this somehow to influence the other one, but I don't see how I'm going to do that. Ooh. There we go. That should do it, I think. So, I mean, I guess this is kind of what you're saying, Chris. It's like I'm just playing around until I get something to work. But this sort of was the most obvious potential issue. It's basically just almost ignoring your inputs. But now we've turned into something where we aren't ignoring our inputs. So we'll see if this works this time. So Y set get, Y get set, and Y set. There we go. Oh no, the get set still works though. Shoot. Okay, so here's one. Wait, no, this is the wrong way. We want true, false, true for number 1. Shoot. Okay, so let's look at this again. So we made this one fail. Now you gotta see how to make this one fail. Oh, it's because this is an empty list. If we just make this... Oh wait, no. If we make this YX equals show X, maybe that would work? I don't know. Set get set set. There we go. Okay. So we just need to make the return types like combine somehow. It seems. So maybe this is more trivial than I thought. Trivial is not the right term. It is easier than I thought. I thought this was going to be harder. Assuming I don't have any errors. But anyway, that's kind of interesting. So we got this one to fail. So here's an example that fails all of them. All right. We're doing these out of order, but that's fine. Okay, so we have our message type. So let's test these things again. So we want get set and set. So we want these functions. And we'll change this to message. Again, this would be a lot easier with quick check, but that's okay. So our structure in this case can be what are the two constructors? Where did it go? Did I not write it in here? Oh, here it is. Really bad error string exit code int. So really bad error hello. And our lens is message. Hmm. 58G, deriving eq. Okay, so that's one of them, and the other one is exit code 0. And then set would be this essentially the same. Message, message, message. So different doesn't matter. There's a lot of versions of these, but so really bad error diff, really bad error val. Structure can be really bad error structure. Oh wait, these are strings, not really bad errors. Okay. And then we need this one where diff and val are that, and then this can just be exit code 0. Okay. So message get set true. Interesting. This one's okay. Is it because I set 0 somewhere up here? Where is it? Oh, interesting. We're making lenses. Is this expected? I'm not sure. Okay. These are all true. Oh, the first one failed. Okay, so these ones are okay. It's just the first one that fails. So this is an example of a data type for number 1. We could just make any data type like this. See you, Chris. I am having fun. So, oh no, this is the opposite. I keep doing that. So, what if we put? What if we? See, now I'm thinking. So this is good. What if we did something weird, like defined? I don't want to write something this long. I was gonna write chocolate chip, but we'll just write chocolate chip. What's another cookie people want to think about? HTML. Internet. Okay, so there's either chocolate chip cookies or there's internet cookies. And then what if we embed this inside of a new type? Like which one? This is weird syntax. Well, it'll happily make us lenses here. So that's a bad sign. And I'm guessing this is trivial enough that this can't possibly be true. I was thinking like maybe if we switch the order, somehow that would screw things up, but I don't think it's going to. And I mean, we can quickly just try the first one, right? So let's get y set. Sorry, set get. And say which one, which the new value can be internet and the structure can be which one cc. Okay. Deriving eq. My guess is this is going to be fine. Which one? Yeah, this is fine. Right, because we're just setting to internet and then checking that that's back, which is obviously the case. It doesn't matter what is in here. So you need a case where setting something and getting something aren't the same. Or setting something and then getting something. I'm just saying the name of the thing. Anyway, okay, this was an attempt. Unsure. We'll look at the examples and maybe try and come up with another one. So we can't use make lenses because we need to define one. So I think this was defined in here, so let me go grab it. What is this? Go away. How do I get rid of this? Remove annotation. I must have clicked this button. Is this an annotation? Yeah. Okay, so we're no longer using so if the structure is really bad error S, this is just S. Exit code anything. It's like empty string. I'm wondering if they just use mempty here, like when they write the code, because it's like when they write the template Haskell, if they just use mempty there. Okay, so setter will be like really bad error S. Really bad error S. Exit code Is that the right one? So we want to change the string, so we should... Well, I guess we could also just return the exit code. That should compile. So if we get a really bad error, change it. But if we get an exit code, just don't ignore it. Something like this. So now, so let's see. So we need to write message set get view message set message val structure equals val, where val equals hello, structure equals really bad error world. Okay, so message set get should work. This should fail. And then these should work. Get set. Yep. And then set should also work. Okay, so that's a valid implementation of the message. Where invalid, but failing the exact same laws as before. So what we want to happen is we want this to pass so if we want this to pass, then we can change this to really bad error S. And then I think these ones should be okay. Yeah. And actually, do any of them fail in this case? Message get set. Okay, so then the second law fails. Is that what we were supposed to have happen? I think it was. Get set fails. Yep. And then message set fine. Okay, that's kind of my thought. Those were the two implementations I was thinking about. Is either this could return a really bad error or an exit code. So that's the difference. So let's put some notes in here. So this can either be E fails set get law, fails get set law. Okay. Did that. This one we'll say again, unsure. We wrote a lens which violated all the laws. That took us a little bit. That was kind of iterative. That was fun. Okay. And now we need to write a lawful lens for this type of that builder string. So this is essentially going to be the build lens, right? Because we have this. So I don't see what we deal with or how we're going to deal with this. Oh, right. Okay, so we're going to have a function and its context. Okay. So lens getter setter, where the getter is going to be a builder. I think this is how you do this. It's called, I don't remember what it's called. Record wildcards or something? Which means we're just going to take build and apply it to context. Record, I forget what this is. Record wildcards. Yep, dot dot, it's only 2 dots. Yep, and then it should get nice. Okay. Setter is going to take a builder and a string. We need to return a builder. But yeah, that's what I was thinking. But what do I do with build? Like, is it just const s? I guess it returns a builder with the same context and builds a function which return. Yeah, that's kind of what I thought. So builder context equals context, build equals const s. Which is weird. Like, this is definitely a weird lens because you're sort of like nullifying this with the setter. Like, this function is no longer useful. But I don't know, maybe there's a reason this could be useful that I just don't know. Anyway, so we're gonna have a build set get view build set build val struct val. So our setter is just a string. Been using hello, so we'll continue using hello. And our struct is going to be a builder what's a function that has that signature? Probably concat. Not concat. So list string to string. Mconcat, I guess. Unwords. Sure, we can use unwords. Unlines. Let's use unwords. It doesn't matter. We'll use that as an example. And then I guess we'll put something in here just for var baz. So build get set build view build struct equals struct. And it can't really be that, it has to be, we're gonna have to apply the function. So hang on, where, what do we need? We need struct, which can be this, and then it should complain about equal. Yep. So what we're gonna do is we're gonna write a function that's like apply context, which takes a builder and returns a string. Apply context builder build context. And then we'll write apply context We'll see if this is valid. But we're going to fill it with, we're basically going to fill this with const, so I don't see how this is going to pass. Because this set operation is going to turn our build function into const s. And then when we apply const, we're just going to get the string. And this, which will be hello or something. We'll see. Okay, build set build diff set build val struct set build diff struct. So we need to define diff, which can just be a string. Hello. Val can be world. And struct can continue to be our same structure. and then we need to do the same thing where we apply context. Apply context. Then that's it, I guess. I don't love that formatting, but oh well. All right, so build, set, get, fine. Build, get, set, fine. Build, set, fine. Nice. Okay, cool. And again, we should be using we should use quick check for this because we won't have to write these. But anyway, it's a good exercise to play with them. Just think about it. All right, so why does this work? Oh, because we're setting after we're building. So right. So when we build this, right, when we actually build this, we're running unwords foobar baz. So this setter ends up being const foobar baz together. So those two things end up being the same because when we apply our context, first we actually build the thing. So we run unwords on this list. But in the second case, we just do const s, which is our build, and ignore the context. So it ends up being the same thing. So that's why that works. That makes sense. Okay, so that's good practice, I feel like. What questions did we not do? We didn't do one, so let's go jump to answers and look at them. My goodness, that was loud. Okay, implement a lens which breaks the second and or third law. Okay, so we'll look at these. Let's start here. Well, let's look at one that's more straightforward, like why. All right, so we have recorder. Our well, we'll just write this in here. Oh, okay, so this one is just gonna play with the history. It's just gonna play with this, and that's gonna break the ones that return the structure itself. That makes perfect sense. The set get will be fine because we're only changing A and then getting it back. That makes perfect sense. I mean, just looking at it now, it makes sense to me. I don't really have to even test it. But I wouldn't have come up with this. Although maybe I should have been able to, because I realized to break all the laws, I needed to modify some kind of state. Like, that's essentially what I'm doing. Okay, so I can see how this would fail. Okay. And then the other one we were unsure about was 4. Let's see what example he comes up with for 5. Oh. Okay. So something that's useful. Well, I mean the history one is useful, but I didn't come up with it. So like what is an example of something that needs to maintain some kind of state? I mean, it's kind of cheating because that's the example he gave us. It needs to include a list that we modify. I mean, I don't know, state. That's very useful. After looking up the answer to 1, seems that anything with an internal state would fail. I'll put state in quotes. Would fail the set, get, and get set and set laws. However, state is a useful tool. How about that? So like anything that maintains an internal state would pass the set get laws, but not the other two. That's an answer. We did it. Okay. Uh-oh. Builders see const nouvelle. Wait, but ours passed them? Did I do something different? C context F. Hmm. All right, so we happen to pick a function. We happen to pick a function that works. So we should try concat, I guess. If we change unwords. Wait, isn't concat and unwords exactly the same in this case? Wait, what? I'm guessing I probably wrote this incorrectly. Hmm. Set build diff. Set build val struct. Set build diff struct. Am I missing something? Oh, that's fun. Yeah, so okay, anyway. Ours is kind of like a state example that fails the getter. Okay, so it's not supposed to pass get set, which implies I'm doing something wrong here. So structure, apply context struct, set, build, view build struct struct. I'm confused. Seems like it's fine. Um, I'm not entirely sure. Anyway, okay. It's a cat. I don't know if that cat is as cute as my cat, but it's still a pretty cute cat. Okay. I'm not sure what to say about this. This seems to work for me. Unless I'm missing a law that I don't, or I type something wrong, which I suppose is possible, but it seems to be okay. Anyway, what time is it? It's 10 o'clock, so we get a little bit longer, so we can talk about virtual field. Hopefully this won't take too much longer. Okay, so virtual fields. We've already seen how lenses take care of the getters and setters for record fields. This chapter covers how to represent virtual fields with lenses. What's a virtual field? I'm using the term virtual field to mean any conceptual piece of data that doesn't exist as an actual field in your record definition. Computed properties or managed attributes are often used to present the data from concrete fields in a more convenient or enriched way. Okay. Nice. Nice snail usage. Yeah. We got some other snails too, which are fun. There's that one. What's the other one called? I forget. Rainbow? Yeah. Sort of rainbow. I like the snails. Also, hey, how's it going? We're learning about virtual fields, which I've never known them to be called virtual fields, but I understand what it means now. So then we need to make lenses temperature. Okay. Sure. This is trivial. Getters and setters. Over. Trivial as well. Those are just behaviors we've already seen. Yeah. Yeah, it's pretty unfortunate that we use this. Also, if you didn't know, that this equation only works between a certain, I think it's 0 and 100 or something. And it's very much inaccurate, but it's close. Exactly. Okay, so these look like just we're combining Celsius to Fahrenheit with the lens, the view lens, or getter, whatever you want to call it. Set Celsius, well, Fahrenheit to Celsius. Sure, that's fine. Yeah, this is a cool idea, actually. I hadn't thought about this. Yeah. We got all kinds of weird units of measurement. They're really fun. I don't know, they're still not as bad as having to deal with the CGS unit system. That is really hard. I forget the exact conversion I had to work out like 30 times during my PhD, but it was something to do with CGS. No, that's easy. I mean, that's just something you look up. Centimeter gram second, like units of energy and these sorts of things. Here, I can show you. Cgs Unit System. Yeah, so you get these ergs and erg seconds and these sorts of things. You end up with these wild conversions between standard and CGS units. Like, just absolutely wild. I've worked it out a bunch of times. I'm sure that I have a notebook somewhere in my basement with the conversions that I did, but I don't remember where it is offhand. Yeah, it's just a particular conversion that I have to do or had to do a lot was pretty unwieldy. Not that generally converting between the two is unwieldy. It's just for the particular equation that I was working with. Oh, it's not multiples of 10. I can tell you that. It ends up working out to like there's this prefactor of 44 point something. I don't remember exactly what it is. But anyway. It's sort of a side topic. Celsius to Fahrenheit. Celsius. We'll have to write that function here in a second. Temp. Ugh, I keep spelling Fahrenheit wrong. Did I spell it right in the other places? Yeah. I don't even remember this. I know there's a minus or plus 32 and a division or multiplication with 5/9 or 9/5. That's all I know. 5/9. At some point I would really like to play with the there's a bunch of unit conversion libraries, or maybe not a bunch, but there's a few that seem really useful. C times 9/5 plus 32. Not sure the parentheses are necessary here. Why won't this? Oh, there's an error somewhere. What is it? Oh, because I wrote getter. And no equal. Anyway, have you already learned ISO? I don't think so. I don't remember what ISO is. As in like isomorphism? I'm not sure what ISO you're referring to. There we go. ISO is an optic. Okay, no, we have not talked about ISO optics yet. ISOs come quite a bit later. I assume there's something more convenient about this with ISO. Oh, I guess that makes sense because there's an isomorphism between Celsius and Fahrenheit. Sure, that makes sense. I see why that's coming up now. Okay. Yeah. No, that makes perfect sense. I didn't realize at first why you were saying that, but I get it now. Yeah, I guess you could have really interesting setters and getters that are even more specific, right? Like you could actually have a Fahrenheit. Yeah, exactly. Like you have there. Okay, so another great benefit of using lenses instead of field accessors is we gain more freedom when refactoring. Let's say as we've developed our wonderful weather app, we've discovered that Kelvin is a much better canonical representation for temperature data. Completely agree. We'd love to swap our Celsius field for a Kelvin field instead. We'll consider two possible universes. In one, this book was never written, so we didn't use lens to access our fields. In the other, the one you're living in, we finished the book and decided to use lenses. Okay. So the universe without lenses. Sad universe without lenses. We had to write the following code scattered throughout our app. Update temp reading. Okay. And then sure. Yeah, this will say Celsius, but we'll be talking about Kelvin. That's no good. Sure. So we have this update temp reading. And then we build a Celsius lens. I see. Okay, that's cool. By adding the replacement lens, we avoid breaking any external users of the type. Even our Fahrenheit lens was defined in terms of Celsius, so it will continue to work perfectly. It's a simple example, but this idea works for more complex refactorings. Yeah, I can see how this would be really useful. Okay, that's cool. Okay. Data. Yeah, we don't know enough. I don't know anything about prisms yet, so I don't have any. I can't really comment on that. We already have username with a capital N, so we'll just remove this and just make it like this. Then we don't have any clashing fields. We could also just turn on the duplicate record fields extension as well, but we don't need it. Okay. So we've decided we're no longer going to have separate usernames and emails. the email will be used in place of a username. Your task is to delete the username field and write a replacement username lens, which reads and writes from to the email field instead. Okay. So we're going to remove the username field, and then we're going to define a username lens, which takes a user and returns a string. So the getter needs to return a string, and it takes a user let's say you. Don't we view email you? And then for setter, we get a U and a name or something. And we'll say set email UN. I think I'm doing something incorrect, obviously. Okay, so something is wrong with our setter. So, oh, this is the string. This is the structure. I think I just had those flipped. So I should be able to get rid of these, but I guess I could also flip set email, but that's going to be weird. So this will be name and user name. Yeah, I guess we could write flip set email and make it point free, but it seems awkward. I suppose this answers the question. I mean, like, if you're actually using this, you're gonna get the wrong answer. If you were expecting like a name, you're gonna get an email now, but I guess that's fine. So we can write full name is a lens that takes a user and returns a string. When setting, treat everything till the first space as the first name and everything after it as the last name. Okay, so full name, lens getter setter. This is kind of like an unsafe thing, right? Because we're gonna have to make an assumption, but that's okay. Doctor of Thugonomics. All right. Sure. Getter. Gonna say view first name name comes first. Maybe I have these backwards. What's the type of this? I do. User name user. I was thinking I had them backwards based on just like thinking. User name so we need to update first name I think that's okay. Again, we're making an assumption that it will work. Oh, wait. Wait, why would this matter? Name here should just be string. What is it? Unwords does what I think it does, right? Oh, it's a list. I think I need words, not unwords. And then this becomes head unwords t. No. It's intercalate. Intercalate, I think. Oh, okay. Unwords does what I think it does. All right. For some reason, I was expecting there not to be spaces, but I think that's probably just implemented as intercalate space, essentially. So this would be my guess. So if we did let user, or sorry, user equals user very pyro val not then full view full name user set full name yeah, that appears to work. It will fail if you do the following. Oh, it will fail if you do the following. There we go. But I suppose you could deal with that by, well, you would want to deal with that by checking your input. We're not going to worry about that.